The picture appears. Good afternoon. I am your last speaker of the day, so anybody that's already gone to sleep, please wake up. You've only got 12 and a half minutes of purgatory to come. I am the Chief Executive Officer of Coldharbour Marine. Coldharbour Marine is going to tell you about this today. We are a 36-year-old company. We started out doing inert gas systems and domestic water systems for vessels. We used to supply a lot out to the Japanese shipbuilding industry under a variety of different brand names, all designed and built in the UK. Sometime around 2008-9, we decided that we would ought to look at this ballast water treatment phenomenon. So we were a little bit late to the party in terms of the commencement of our development, but we thought we'd have a look at it anyway. And we spotted very early on that there were going to be a lot of players in the market, and there were going to be a lot of similar players in the market. There were going to be a lot of filters, there were going to be a lot of UV lamps, there were going to be a lot of chlorination-based systems, chemical-based systems, ozone-based systems, you name it. It's there. What we decided, however, to do was something a little bit different. We decided that we would optimize our technology for one particular type and class of vessel. So we are, if you like, the pioneers of the niche application. We're the pioneers of the people who said not one technology is suitable for all types of vessels. So we developed our gas lift diffusion type process, which is targeted at large tankers, large bulkers, large LNGs, vessels with very high ballast pumping rates, extended ballast legs, and critical timings on terminal, where any kind of delay, any kind of disruption to normal ballasting and terminal procedures would be potentially costly, if not disastrous. So our focus was on that, and because we were already making an inert gas plant at that time, we decided that the best place to start was to see whether we could apply our inert gas plant to ballast water treatment. That would certainly make it easy for tanker operators, for example, to put their arms around the technology. So when we started to look at ballast water treatment systems, it became clear that we were never going to be a mass market player. So unlike everybody else, we're geared up for comparatively small numbers of units to be sold through, of our type. We're not looking at the kinds of numbers that our colleagues at Alfa Laval or even Irma or others would be looking at. We're sort of a strictly less than 100 units a year type operation, but very specialized. So we look at the kinds of considerations that BWT system choice has for you, the ship owners and operators, and you're already aware of many of them, be they specialist maintenance requirements, crew training, if you're using filtration plant on board, what the pressure drop and how you recover that, whether or not you've got enough available electrical power. We've heard that several times today in relation to a number of technologies, how much space you've got on board, especially when it comes to retrofit, the practical risks inherent with certain types of technologies, chemicals associated, hydrogen production and so on and so forth. And then beyond all of that, we wanted to look at the operational issues. Can the crew use it? What happens when it goes wrong? And so on and so forth. And just when you thought you'd got your arms around all of that, along comes MEPC 70 and the supposed revised G8 requirements. Now, basically, what revised G8 does is address some of the unspoken about gorillas in the room that actually the industry as a whole has been aware of for quite a long time. The amount of holding time post-treatment that systems have been tested to. For US Coast Guard, it's still only 1 day, believe it or not. For IMO, it's 5 days. Many large vessels in our target sector could have ballast legs of 14 days, 20 days, 30 days, in some cases 42 days. Well, if you've not tested for regrowth over that limit, how do you know that you're not going to be in breach of discharge requirements when you reach the port of discharge? Then there's the question of scaling. It's good that some of our colleagues around this table have tested the largest units that they have available for their shipboard testing. That represents sound engineering principles. I have to tell you that many vendors out there have only ever tested the smallest system they have available for a ship and then taken out their Audi book of magnifying glasses and decided that if they make something 10 times bigger, it will therefore have 10 times the capacity. Any of the engineers in this room will tell you that scaling is not linear and it doesn't work that way. So it's great that revised G8 and to a certain degree US Coast Guard type approval starts to look at this issue of scaling. And also the real life operating parameters. What are the total suspended solid levels really in typical ports? What are the typical temperature operating ranges? What are the typical salinities that would operate for the system? And the combination of those things together. Sometimes people have looked at them in isolation, but if you have very cold and very dirty and low salinity water, how does that impact overall on performance? All of those things have to be taken into consideration because, contrary to what some people will tell you, the Ballast Water Management Convention and the US CGEPA rules are discharge standards. They are not treatment standards, and you really do have to keep that in mind. So, we say, what systems are fit for purpose? And when we pitch our own particular product into that, we look at what might be required for relatively small vessels, up to say an Aframax, with relatively short ballast legs, quick turnarounds and so on and so forth, versus the larger vessels that we talked about earlier with the longer ballast leg requirements. Now there are a number of very good, very high quality technologies available for the smaller type vessels. Some of them are sitting here today, and as some of these gentlemen will attest, we as a company actually refer owners and operators of those kinds of vessels to those companies because we know that they will do the job properly. On the larger vessels, however, we claim that our in-tank solution is the best. And this is why we claim. If you have a large vessel and it's docking, and it's on terminal somewhere, and it's taken its ballast on board, for those first 7 days after ballasting, for maybe those first 10 days after ballasting, your standard treatment is absolutely fine. In some cases, depending on the biota and the time of year, you may be in trouble a little earlier than that, but you will get regrowth with any ballast water treatment system at some point during that voyage. There is no such thing as 100% kill on any ballast water treatment system on the planet, nor will there ever be. However, at some point, you will get regrowth. Now, some technologies offer you the opportunity to retreat on discharge, other technologies don't. The question is, we'd rather that we just treat once, because every time you have to turn that treatment system on, you are recognizing that you are running a risk of disruption of some sort. Not everything runs like clockwork 24/7, 365 days a year. So you have to build in the realistic proposition that you might have a breakdown, you might have a blockage, you might have something that doesn't quite work properly for you. What we do is we ballast as normal on a terminal, and we have no inline filtration whatsoever. We do not touch the ballast lines at all. We have no impact on the current ballasting procedures. So the gentleman earlier this morning who said no such thing as gravity deballasting anymore, good news for you is gravity ballasting is still alive and well with our system, provided you've got a big enough suitable ship. For our system then, we use the inert gas generator to treat the ballast water in the tanks at some point during the voyage, and that gives you the flexibility of when you do the treatment. Okay? This means that it doesn't matter how long your ballast leg is. It can be 40 days long if you like. It doesn't matter if your original ballast leg gets changed for some reason. You have to sit off terminal for some period of time. Makes no difference. You just time your treatment to the point where you anticipate to arrive, and you will therefore always arrive treated. Because remember, the critical issue here isn't what's going on in the treatment system, it's how we protect your revenue, how we protect your charter contract. That's what all ballast water treatment companies are about, making sure that you are compliant. Here is a typical layout that we have done. We've actually used this on a VLCC. I should mention when we look at that G8 scaling requirement that our shipboard testing, which was taken under UK Maritime Coast Guard Agency supervision and was actually had Lloyd's Register sitting on our shoulders for everything that we did, was conducted on a VLCC. So the point that Konstantinos made earlier on, which is that because they accidentally fell into a very good habit when they were doing their original G8 testing, means that essentially they've already tested to revise G8, actually applies to Coldharbour as well. We tested over a very wide salinity range, very wide temperature range. Because we have no filter, a very wide total suspended solid range, we also tested for our ship-based testing on a very large crude carrier. We were actually the first BWT company to retrofit a very large crude carrier. The process is we produce the inert gas, we compress it, we cool it down, we send it along the main deck to gas lift diffuser units mounted inside the ballast tanks. There are no moving parts, there are no maintenance parts, and every ballast tank effectively has its own monitoring system. So you have zero risk of undertreatment, you even have zero risk of overtreatment, because every tank across the ship is monitored independently for performance standards. So, that means we have no issues with upscaling, as per revised G8. We have no issues with regrowth, as per revised G8. You're having a known technology, which means it's easy to embrace. We give you a guarantee of no disruption to terminal operations. That guarantees your bottom line and your charter contract. We don't use any power whatsoever during terminal operations, so you're always going to have enough electricity available for us, regardless of the size of the ship. And we make no connections to the ballast lines whatsoever, so there's no pressure drop or whatever. And because it's fully modular and because it's not linked to anything in the pump room, we can pretty much install it anywhere on the ship. For a new build, we would also offer you the proposition of being able to use the inert gas plant for 2 jobs. Therefore, that saves you one whole system on board for bulk inerting or cargo blanketing and ballast water treatment. And we can do that for LNG carriers as well, where we offer the option of running the IG off LNG boil-off, so it makes it even cheaper. Let's look at the final part, which is the certifications and rewards. I think I have 1 minute left. As we said, we were a comparatively late certifier. We actually didn't achieve our type approval certificate until end of Q1 2015. So we're a late arriver in the market. Sorry for being a bit late, but we were tested extensively by UK Maritime and Coast Guard Agency. We're actually only the 2nd system ever approved by UK MCA, and I don't recommend any of my colleagues to go and try and test with MCA because they put you through the ringer. That being said, it's always nice to come out the other side and to know that we're already well in compliant with revised G8. In fact, we're a bit more compliant than that because UK MCA made us test down to 2 micron organisms, not the 10 micron organisms required by IMO and US Coast Guard. So we're even a little bit future-proofed against that as well. The AMS was granted in June 2015. I note the cynicism in the room surrounding AMS, but I understand why. I think we all understand why, but it's there and we have it. And we were the 17th company to register for full US Coast Guard type approval. We are a little later than our colleagues because, oh, look at that. We're a little later than our colleagues, primarily because being an in-tank solution, we can only go to a handful of test facilities. We cannot test on a normal inline test facility. We actually need a facility that simulates a ship's ballast tank in order for us to be able to do our land-based testing. That doesn't come available to us until the end of next year. Other than that, we genuinely believe we have no problems at all, and we're an award-winning ballast water treatment system, and I'm overstepped by 15 seconds, so I'll go and sit down. Merry Christmas, Happy New Year, good luck.